Hello guys, in this very lesson we're going to be solving together the fourth worked example on circular motion under physics. So if you want to flex your mental muscle, I'll give you a very short time to do that right now. Welcome back guys. For those who cannot solve this very question right here on the board, please come with me and let's see how we're going to tackle this very question right here on the board. So what do we have? It is desired that the outer edge of a grinding wheel, 9 centimeter in radius, move at a rate 6.0 meter per second. That's a linear or tangential speed. Solve for the length of the thread that could be wound on the rim of the wheel in 3 seconds. Now, first of all, let's have a pictorial, understanding of what we're about to work with. Now, we have a wheel here. It's not going to be easy trying to draw a wheel, by heart. Let's say there's a wheel. So you have a wheel here like this. Wheel, a kind of a wheel in a machine. So there's a wheel. Don't forget, as this wheel is working, just like wheel and axle, as this wheel is working, we have this wheel in a grinding machine. As this wheel is working, we have something in this very wheel. There's something about this wheel as this wheel is working. Now, a thread is being wound. Now, this thread is being used to start this wheel. Or probably while this wheel is in motion, the thread could be wound around it. To be wound around something means to be tied around it like this. So this very wheel has a radius. What radius does this wheel have? You have a radius of 9 centimeters. Don't forget the radius should be in meters. So how do we convert this to meters? 100 centimeters make 1 meter. So if 100 centimeters makes 1 meter, then 9 centimeters is going to be 9 divided by 100. So we have 0.09 meters. So this is already sorted. You have this already. Now this very wheel has a radius of 9 centimeters. This is already interpreted. So now what are the other quantities given to us? So move at a rate of 6 meters per second. Now it moves at this rate. 6 meters per second is the linear or tangential, velocity or speed. So let's take that out also. So we have the 6.0 meter per second. Now we have those two quantities written out or parameters written out. Now solve for the length of the thread that could be wound on the rim of the wheel in 3 seconds. Now, before we even go into this, now the first thing is don't forget something. We're talking about the length of the thread that could be wound around this. The length of the thread has to be in meters. So this wheel, you can see this wheel, this circular wheel, for the fact that a thread will be wound around it. So as the thread is being tied around or wound around it, the length of the thread has to be in meters. So now before we even go to that, first of all, we have this linear speed. Then we have the radius, so we can easily get the angular speed at which this very wheel, is moving. So we're going to do that right away. The linear speed, which is v, is equals to angular, speed times radius. That's why it's very, very important. You have all the formulas. So if you've not seen the previous lessons where most of the formulas were derived, I would love you to quickly do that. If not, you find it very hard to keep up. So what do we have? This is the linear speed of 6 meters per second. The angular speed, which we are looking for, then times the radius, which is 0.09 meters. So linear speed is this, and this is radius. So we're going to divide both sides with 0.09. So what do we have? We have the angular, speed or angular velocity as 6 divided by 0.09. So that was 6 times 100 here over 9. Just take it, just under 2 decimal places under here, no decimal place. The 2 comes up as 2 zeros, 100. So what do we have? That's 3 here, 2, 3 here, 3. So what do we have? 2 times 100 is 200 divided by 3. So we can put this in form of decimal. So 3 in 20 is 620, remainder 2, 3 in 20 is 6, remainder 2, like that, recurring decimals. 66.66666. So what do we have? We have 66.7 rad per second. So this is what we have right here. This is our angular velocity. So this very body was moving at the speed, at the rate of 66.7 radians in 1 second. So we've gotten this already. So the next thing, after we've gotten this, the next thing you're going to do now, you're going to look for a way. And don't forget, we're talking about the length of the thread that could be wound around this. So since we've gotten this, now we've gotten our angular speed. So the next thing we're going to do is that we're going to look for a way to get the length of the thread from what we have right here. So what we're going to do next, now don't forget, 66.7 rad per second. So how do we now equate this? How do we relate this with the length of the thread? Now don't forget, for the length of the thread, for every complete, for every complete cycle or every complete revolution round this circular wheel, for every complete turning, is equal to one revolution. So that means you're going to look for a way to convert this radians to revolution. Although there's a standard unit for angular speed, but you're going to, be using revolution per second so around. So this is already in second, just rad to seconds. So you're going to look for a way to convert the 66.7 rad to seconds. So what do we have? 66.7 rad to seconds, to rev, I beg your pardon. This already in seconds. This rad per second, so rev per second, so seconds already sorted. So now we're going to look for a way to convert the rad to revolution. So what's the relationship between rad and revolution? We've done this a couple of times. Don't forget the total distance around the circle, which is a circumference. Circumference is 2 pi r, which is one revolution around the circle, which is equals to 360 degrees. 2 pi r is 2 pi times radians, 2 pi radians. So circumference of the circle, one full distance around the circle, which is circumference of the circle, is 2 pi times 1 radians equals to 1 revolution equals to 360 degrees. So when we have 66.7, a rad, that will be 66.7 rad equal to x revolution. So what I'm going to do next, I'm going to cross multiply. So 2 pi radians, so 2 pi times r, that's 2 pi, that's 2 pi, that's we're talking about 1 radians. So that's 2 pi, this is the 6.7 rad times a, so that's 2 pi x equal to 66.7. Don't forget, we are looking for this in radians. So what do we have? 2 pi divided by both sides, 2 pi. So what do we have? We have x equals to 66.7 divided by 2 pi in revolution. So if 2 pi rad is equal to 1 revolution, the 66.7 rad is how many revolutions? That's what we have right here. It's 66.7 divided by 2 pi revolutions. So we have the stuff already in revolution. So let's take off what we have right here, to keep on very close to getting the length of the thread that was wound around the very wheel. So let's see what we're going to do next. So we have this already. We have our angular speed in the new format. We have 66.7 divided by 2 pi. That's a new angular, velocity. 66.7 divided by 2 pi revolutions. That's what we have per second. Use it here per second. So this very, don't forget, it was 6.7 rad per second, but now it's 6.7 over 2 pi per second. So the question is, what's the length of the thread that could be wound on the rim of the wheel, on the rim of the wheel is displaced in 3 seconds. So if in 1 second we have 66.7 over 2 pi revolutions, then in 3 seconds it's going to be what? In 3 seconds, it will be 66.7 over 2 pi times 3 over 1. That's what we have. So right here, I think we can use our calculator to help ourselves with this. 66. I'll love the pi to stay put. So that's going to be 66.7 times times 3 divided by 2 divided by 2 pi. Okay, we will put our pi also. Let's put our pi. We take that off. So what do we have? We have 31.846. 66.7 times 3 divided by 2 pi will give us 31.846. So that's 31.8, revolutions in 3 seconds. So we've gotten this already. We've gotten 31.8 revolutions in 3 seconds. You can see how easy this is. So since this very body will make 31.8 revolutions in 3 seconds, now the question is, how do we then relate it with the length? How do we relate it with the length of the very thread we're talking about? So 31.8 revolutions in 3 seconds. So this already sorted. So how do we relate 31.8 revolutions with the length of this very thread? So don't forget, this is a wheel. As has been said here, one complete revolution is equals to the circumference around this very circle, which is 2 pi r. So that means 2 pi. So let's get the circumference first. What's that going to be? Circumference around the circle, 2 pi times radius. What's the radius? 0.09 meters. So if the circumference is this, which is 1 revolution, so what's it going to be then? So 2 pi times 0.09, then convert as 2 pi times 0.09. What do we have? We have 0.56548. So that means one circumference, then one revolution is 0.565 565. Let me put that to four decimal places. 5655 meters. So if one revolution is 0.5655 meters, then 31.8 revolutions will give us how many meters? And this is going to be the length of the of the thread. By the time the thread goes through one complete cycle on this very circle, it's going to work complete. That means the length of the thread will be about 0.5655 meter of that very thread. So that's what the circumference is. So if that is it, then 31.8 revolutions, which is in 3 seconds. In 1 second, this is what happens. In 3 seconds, we end up, we end up having 31.8 revolutions. So what would be the length of the thread that will be involved in this whole, circular motion? So I'm going to cross multiply 1 times x, this x, then 31.8 times 0.5655. Quickly, let's solve that right away. So the answer we got is 31.8. That'll give us 17.98 meters, which is approximately 18 meter. That's the length of the thread that is involved in this whole circular motion. As you can see, the question, looks quite very tricky, but it's very, very interesting and quite straightforward. You just need to have the formulas always. If not, there's no way you'll find this easy. So it's as simple as that. So at this very point in time, we're done with this very lesson. If you found this very lesson helpful, please follow me at at Revelation Hub on Facebook, and also subscribe to this very channel at Edge Mosaic. And please share this lesson also with others. See you in the next lesson. Thanks.